Hello, this is Mr. Stansbury. I'm going to take you through the 13C1 assignment for the problems that we had to do. All right, number one, find the final value of a compound interest investment of $4,500 after 3 years at 6% PA, which again stands for per annum. Okay, with interest calculated annually. All right, so for part A here, let's use blue, that looks nicer. Part A here, we're going to just put this into our formula, okay? And if you'll remember our formula that I mentioned in the notes, and again, this is not in your IB book, but you used it a bunch in Algebra and Algebra 2. So we're going to try this one. A equals P times 1 plus R over N to the N T power. Okay, use that, and that makes these all pretty straightforward and simple. Okay, so your original investment is $4,500, so that's your P. So we're trying to figure out what the amount's going to be after your investment, initial investment of $4,500 times 1 plus your rate, and this is, remember, rate as a percent. So there's 6%. So to turn that percent into a decimal, move the decimal over twice, and it's 0.06 divided by N, the number of compounding periods per year. And since this is calculated annually, those N's are just going to be 1. So there's a 1 for that N, a 1 for this N, and then T is the amount of years, so times 3. So really this is just 4,500 times 0.06 divided by 1 is 0.06, so that's 1.06. 1 times 3 is 3. Okay, so we can just plug that into our calculator. 4,500 times 1.06 to the third power gives us 5359.57. 59 point, what did we say? 57. Okay, so that's how much it's going to be worth after 3 years. All right, part B, 6,000 after 4 years. So again, same idea, with all three of these really are the same idea here. So we'll just plug in our original investment, 6,000 times 1 plus 0 point, and that's going to be 0.5, that's 5%. It's calculated, all of these are calculated annually. So, and that's 1 times 4, because there's 4 years. So this is simply 6,000 times 1.05 to the fourth. Okay, so 6,000 times 1.05 to the fourth power gives us 7293.04. Okay, so that's what the amount will be after 4 years. All right, and then part C. Now it's just changed from dollars to pounds. No big deal here, same calculations. So A equals 8,200 times, and again there's our decimal, move that over twice, so it's 1 plus 0.065 calculated annually, so that's 1 compounding periods, all times 1 times, and this is at 2 years, so our calculation is going to be 8,200 times 1.065 to the second power. All right, so we get 8,200 times 1.065 to the second. All right, and we get $9,300.65 is going to be what you're going to end up with. All right, okay, so there's, oh, and that's not dollars, sorry, that is, this is pounds, right? Because that's that little goofy L, the cursive L. Let's give this a go. It looks like a weird FTL together. But you get the idea. All right, moving on. Number 3. Mailing invests $15,000 into an account which pays 8% per annum, compounded annually. Find the value of her account after 2 years. So, same idea as the first one that we were doing here. So, A equals our initial investment, $15,000, times 1 plus our percentage rate. So there's 8. Move that decimal back twice. 0.08. It's compounded annually, so that means it's just a 1 for the compounding periods. And then that's 1 also goes here. Value of her account after 2 years, so 1 times 2. So in our calculator, we'll put in 15,000 times 1.08 to the second power. All right, 15,000 times 1.08 to the second power gives us 17,496. Okay, so they end up with, so mailing ends up with $17,496 after 2 years. So the total interest earned is going to be, so she started off, or he started off with 15,000, end up with 17,000. So we just got to find what the difference of those two is. So B, we're simply going to take our ending amount, 17,496, and subtract off our initial investment, and we'll see how much that they made. All right, so they ended up making $2,496 on their investment. Okay, moving on. All right, our next number 1. Mac places $8,500 in a fixed deposit account that pays interest at a rate of 6%, compounded quarterly. So this is a little different than the other ones. How much will Mac have in his account after 1 year? So A equals, P is our original investment, so that's $8,500 times 1 plus our rate is 0.06 divided by, and then this is the number of compound periods per year. So if it's quarterly, that means there's 4 compound periods in that year. So there's going to be a 4 here and also a 4 here. So again, remember, this is our A equals P times 1 plus R over N to the N T formula that that I showed you in the notes. Okay, so we also now have to multiply that by the number of years, and that years happen to be 1 here. So we get A equals 8,500 times 1 plus, let's see, 0.06 divided by 4 gives us 0.015. 1.015. Let's see, 1.015. 1.015, all to the 4 times 1 is 4th power. So let's figure out how much money they're going to have after a year. 8,500 times 1.015 all to the 4th power ends up with 9021.59. Okay, so that's how much they'll have in their account after 1 year. Okay, next problem we have here is number 2. Michaela invests her savings of $24,000 into account, pays 5%, compounded monthly. How much interest will she earn in 3 months? So first thing we got to do is figure out how much she ends up with. So A equals, the P is the principal amount invested, so that's our $24,000. 1 plus the interest rate. Move that decimal back twice, and we're at 0.05 divided by the number of compound periods. So monthly means that you end up with 12 compound periods per year. Okay, so that 12 goes there. That compounding periods also goes there, and we multiply it by 3 months. Now this is supposed to be years up here, and it is years. So we have to actually figure out how much of a year 3 months is. 3 months is. A lot of people will end up putting the 3 here, but actually it's going to be 3 divided by 12, right? That tells us that we have 0.25. That's only for a quarter of a year. So it's 12 times 0.25 is what we're going to put up there. So we get a ending amount is going to be 24,000 times 1 plus, let's figure out, not 1 plus, but 1 point. Figure out what this is here. And you can actually enter this whole thing into the calculator just as it is, and that will be just fine. So really your thing that people mess up a fair amount is this part up here. So let's try this instead. Let's leave this 1.0.05 over 12, and then that's all. Only thing we need to do really to make sure that we get this right is to calculate this first. So a quarter of 12 is just 3. So now in our calculator we'll just enter this in. So we got our 24,000 times, and I'm going to do this now in parentheses because it's a couple of different pieces. So we'll do 1 plus 0.05 divided by 12. Put that all in parentheses. That order of operations will take care of this, and take that all to the third power. And that gives us that they're going to end up with 24,301.25. Okay, so that's what they're going to end up with after the 3 months. Now, again, this is not our answer because they're asking how much interest will she earn in 3 months. So you actually got to take the 24,000 away from the end amount to figure out how much interest she earned. So we got, again, we ended up with 24,301.25, and we got to subtract off the 24,000 that she originally invested, and we end up with $301.25 is how much interest she earned. Okay? All right. Moving on. We've got, let's see, number 3, compared the interest paid on an investment of $45,000 at 8.5% per annum over 2 years if the interest is simple interest. Now remember, anything that's simple interest we don't need to worry about anymore. So just don't even bother with that. We're just going to go straight to part B, which is compounded half yearly. Okay, so every half of a year it's going to compound. So that means that our N is going to be 2 on this one. Compounded quarterly, that means it happens 4 times a year. So that N over here is going to equal 4. Okay, so let's do part B. So the original investment is 45,000 times 1 plus 8.5 as a decimal is 0.085 divided by excuse me, the number of compounding periods. So that's every half of a year, so that's going to be 2 times per year, and that 2 also goes up there. And then this is over 2 years, so that the T is going to be also a 2. So our ending amount is going to be what we'll want to put in our calculator, 45,000 times 1 plus 0.085 over 2, and then 2 times 2 is 4. So, oops. Oh man, messed that up. There we go. Oops. So, we've got in our calculator, we're going to do 45,000. And then parentheses 1 plus 0.085. Divide that by 2. And then we're going to take that to the 2 times 2 is 4. Okay, and then we push enter, and we end up with 151.65. Okay, so that's what they end up in. But now if you'll notice here, the question says compare the interest paid on an investment. So we actually we want to figure out what the interest is going to be. So we're going to take our ending amount, 53,151.65, and subtract our original 45,000. Oops, one too many zeros there. That was invested. And we end up with 5,1. Let's see, that's going to be, let's see, we got to borrow one from that, right? And we end up with $8,151.65 is the interest on part B. So let's find the interest on part C. So it's going to be the exact same setup. Everything's the same, except for now, instead of n being 2, now n is 4. So I'm just going to take this information here, copy that down, 45,000, and I'm just going to make sure that I change my n's from 2's to 4's. So we got 1 plus 0.085. It's now compounded quarterly, so there's going to be a 4 here and a 4 here. So those two 2's turns into 4's, but that 2 is the number of years, so that stays the same. So now what we're going to put in our calculator is 45,000, 1 plus 0.085 over 4, all to the 8th power. Okay, so really what we can do here is we don't actually have to re-enter all this information in. If you do second entry, it'll bring back the same thing that we just did. And if I go back, I'm going to want to change that 2 into a 4. And then I want to turn that 4th power into an 8th power and push enter, and we get 53,243.80. Okay, so that's what the amount they're going to end up with on that one is. So the interest is going to be our 53,243.80 minus, oops, that's a 3, minus our original $45,000 investment. Okay, so that gives us, borrow one from there, and that gives us $8,243.80 here, and $8,151.65 here. So the half yearly versus the quarterly. So you can tell it's not really that dramatic of a difference. Let's actually figure out what the difference is, because I think that'd be pretty important, right? So let's do 82.43.80 and find the difference between that and 81.51.65, right? So that gives us 0.15, and then that gives us a difference of $92.15 over the 2 years. So hey, 92 bucks is pretty good, but not a really big dramatic difference considering you originally invested $45,000 and it's over 2 years. It's a difference of $92. All right. Okay, moving on. The next number one, Ollie places 9,000 pounds in a savings account that pays 8% per annum, compounded quarterly. How much will she have in the account after 5 years? So let's set this up. The ending amount is going to be our original investment, 9,000 pounds. There's 1 plus, turn that 8 into a decimal, 0.08. That's an 8, sorry. Still doesn't look like an 8. Let's change it. There we go. Over, let's see, compounded quarterly, so that means that our n is going to be 4, because there's 4 compound periods per year, so 4's go in both those spots, and it's for 5 years, so 4 times 5. So in our calculator, we're going to put 9,000 times 1 plus 0.08 over 4. 4 times 5 is 20. Okay, so we've got 9,000. Parentheses 1 plus 0.08 divide by 4 all to the 20th power gives us a good amount of money, 13,373.53. Let's see, was that right? 13,373.53. That is going to be the ending amount. So that's how much you'll have after 5 years. So again, that's like $4,300 in interest. That's pretty good deal. All right. And remember, that's pounds, not dollars. Sorry, I said dollars. But anyway, next one, number 2. How much interest? Again, you got to pay attention to what they're asking you. How much interest would be earned on a deposit of $2,500 at 5% per annum, compounded half yearly for 4 years? So, A equals original investment of $2,500 times 1 plus 0.5% is 0.05. And then it is compounded half yearly, so that means N is 2. So we've got a 2 down here and a 2 there, times the time, which is 4 years, so that's times 4. So we're going to want to plug into our calculator 2,500 times 1 plus 0.05 over 2 to the 8th power. All right, so let's try that out. Parentheses 1 plus 0.005 divided by 2 all to the 8th power gives us 3046.01. All right, so that's how much they're going to end up with at the end. But now again, remember, it asks us how much interest would be earned. So we're going to want to take that 3046.01 and subtract our original investment of $2,500 and see what we end up with. Right? And that means we end up with $546.01. That's how much interest they're going to end up earning. That's how much extra money they are going to end up with. All right? Okay. Next one, number 4. Jay. I'm going to go with Jay on that one. Jay recently inherited $92,000. Lucky Jay. And must invest it for 10 years before he spends any of it. Okay. 2 banks in his town offer the following terms. Bank A, 5.5% compounded yearly versus Bank B, 5.25% compounded monthly. Which bank offers Jay the greater interest on his inheritance? Now, that's a pretty good question, because you're going to want to figure out what he wants to know, what's going to get him the most money, since he can't spend it for 10 years anyway. So let's figure both of those out. So we got Bank A. Let's see, we're going to do his ending amount equals the original investment of $92,000 times 1 plus 0. Let's see, that's 5.5%, so 0.055 divided by compounded yearly, so that's going to be a 1 here and a 1 here, and it's for 10 years, right? Bank B is going to be pretty much the same thing, except for it's just these are going to change, and of course a little bit different percent too. So our A is $92,000 for our principal amount, times 1 plus 0. This is 5.24%, so that's 0.0525 divided by compounded monthly, so that's going to be a 12 here and a 12 there, and then the years are going to be 10. Okay, so on this one here, plug in the calculator, we're going to have 1,000 times 1 plus, well, really it's just going to be dividing by 1, so it's 1.055 to the 10th power, right? So let's calculate what that is. So we got 92,000 times 1.055 to the 10th. Going to end up, wow, that's a pretty good amount of money there. So 157,149.29. Right? Did I get that right? That's a lot of numbers to remember. 157, 149.29. Okay, so that's how much you end up with in that option. Bank B is going to equal. Gosh, I butchered that. That does not look good at all. Bank B, there we go. A equals 92,000 times, let's just leave this, 1 plus 0.0525 divided by 12. And then 12 times 10 is 120. So we're going to put that into our calculator there. Okay. So we got 92,000 times parentheses 1 plus 0.0525 divided by 12, all to the 120th power, and it ends up with 155,344.23. 155,344.23. Is what he's going to end up with from Bank B. All right, let's. I just want to double check I got my numbers right. 155,344.23. So it says, which bank offers Jay the greater interest on his inheritance? And it is definitely this one. He's going to end up making almost $2,000 more in that 10-year period if he goes with this one. All right. Okay. Last problem then. Sven sells his second house and deposits the proceeds of $87,000 in a term deposit account for 9 months. Account pays 9 3/4 per annum compounded monthly. How much interest will he earn over this period? So, A equals original investment of 87,000 times 1 plus, so 9 3/4 is 9.75. Move that decimal over twice, and we're 1 plus 0.00975 divided by compounded monthly. So the n is then going to equal 12 here, and a 12 there. And it says for 9 months, not 9 years, but 9 months. So 9 divided by 12 tells us that is that's 0.75 years. Right? So it's going to be 12 times 0.75. All right? So if we take 12 times 0.75, that's going to end up giving us a 9 here for our power that we're going to want to enter in. So A is going to end up equaling 87,000 times 1 plus 0.0975 over 12 to the 9th power. That's what we're going to want to enter into our calculator. Okay? 87,000 times 1 plus 0.0975. Divide that by 12 and take that all to the 9th power, and we end up getting 93,572.60. Okay, so that's how much money Sven is going to end up with after those 9 months. Okay, but now again they ask for the interest, so we got to take our 93,572.60 and subtract the original investment of 87,000 to see what kind of interest he ends up earning, right? So there's that. Borrow 1 from there, and we get 7 from 13 is he's going to end up making $6,572.60. All right? Okay. So that's it for this one here. If you have any other questions at all on this assignment, please feel free to ask in class. Thanks.